Okay, so when I say the word concrete, you probably think of sidewalks, maybe a skyscraper, right? But what if I told you it's at the very heart of a revolution in how we manage electricity? I know it sounds kind of crazy, but that's exactly what we're diving into today.
Think about this for a second. The transformer, that piece of technology that's absolutely essential for our entire way of life, is basically running on a design that's over 140 years old. Sure, it works, but in an age of smart grids and renewable energy, that old design is really starting to show its wrinkles.
So let's peel back the layers on this ancient secret of the grid. See, the problem isn't just that the tech is old. It's that the core idea has a built-in flaw that we've just been, well, working around for more than a century. The key word there is force. Old school transformers grab a magnetic field and literally jam it through a steel core. And this act of forcing the field to go where it doesn't want to go naturally, well, it creates resistance. And resistance means wasted energy, a ton of extra heat, and you guessed it, limited performance. And this right here, this is the whole story. The old way is all about fighting physics, forcing the flow. The new way is about working with physics, letting the magnetic field just follow its natural path. This one simple shift from forcing to following is what unlocks these incredible gains in efficiency. Which brings us to the big breakthrough. And the solution comes from a material that we see every single day, just completely reimagined. This, my friends, is the concrete revolution. So, meet magnetizable concrete. Now, this is not your typical sidewalk mix, not at all. It's a patented, high-tech composite material that's been specifically engineered to concentrate and guide a magnetic field. Instead of forcing it, it basically creates a superhighway for the field to flow through smoothly, and that just slashes energy loss. And here's a look at how it actually works. You can see the electrical coil is embedded right inside that special concrete core. The core itself creates this perfect, low-resistance path, guiding the magnetic field exactly where it needs to go. No more fighting. It's just an elegant, super efficient flow of energy. So this revolutionary material is the heart of a whole new kind of transformer. Let's meet the MagPower 3H team. And that 3H, by the way, stands for high power, high voltage, and high frequency. So what does this new design actually give you? Well, it's all built on that patented tech, which leads to some seriously high performance. It's also way safer and more eco-friendly, and this is huge for modern infrastructure. It's modular and totally scalable. Let's talk performance for a second. We're looking at an efficiency of over 99%. That is an unbelievably small amount of energy getting lost during the transfer. Now, in a world that's all about conserving energy, that last percentage point makes a massive, massive difference when you scale it up to the level of the whole grid.
And here's another huge advantage. It can operate at really high frequencies. We're talking up to 100 kilohertz. For transformers, higher frequency means you can get the same amount of power out of a much smaller, lighter package. And that opens up all sorts of new possibilities for places where a big, bulky traditional transformer just wouldn't fly.
But the benefits don't just stop with performance. You know how traditional transformers are usually filled with oil for cooling? Well, that's a major fire hazard. The MagPower 3H10 is 100% oil-free. It's air-cooled, which completely eliminates that risk. On top of that, its magnetic bits are actually made from recycled materials, making it a much more sustainable choice all around. Now check out how this tech builds out. This is where that modular design really shines. On the left, you've got the core, single unit. Then on the right, you can see how you just stack and combine them to create a powerful, scalable system that can be tailored to pretty much any need. This table really gives you a sense of the raw power we're talking about. I mean, look at this. It handles power from 200 kilovolt amps all the way up to 5 megavolt amps, and it can take on primary voltages up to 36,000 volts. This isn't just some lab experiment. It's a seriously powerful and versatile piece of engineering that's ready for prime time.
So with all this innovation, where does it fit in? Well, this isn't just about replacing what we already have. It's about enabling what's coming next. It's really about powering the grid of tomorrow.
I mean, just look at this list of applications. These are the absolute cornerstones of our modern world. Power-hungry data centers, renewable energy from wind and solar, smart grids, those huge EV charging hubs. All of these incredibly demanding applications are just crying out for a more efficient, compact, and safer transformer. And that's really the bottom line, isn't it? This isn't just a tiny improvement. The source material calls it a breakthrough, and it's so easy to see why. It's a complete fundamental rethinking of a core technology, and it's showing up at the perfect time for this global push towards electrification and smarter energy.
So I'll just leave you with this one question. By looking at a really old problem from a totally new angle, by letting magnetic fields flow naturally instead of fighting them, and by using a material as unexpected as concrete, we've basically jumped forward 140 years. It really makes you wonder, what other ancient technologies are out there just waiting for their own concrete revolution?